Hello all, welcome to my channel. I'm back with another video. In this video, we will discuss about Flink's checkpointing. So while in my previous video, while I was discussing the Flink's dashboard, I mentioned checkpointing to be a very important thing that we have to see and note down the metrics related to checkpoint because that's how Flink's jobs maintain state and maintain fault tolerance. So let's get started. So what is Flink checkpointing? Checkpointing. So in Flink, checkpointing is a process in which we take a periodic snapshot of an operator's state and store them in a distributed or a reliable file system, so that in case any failure happens, we can read from that snapshot and processing the data from that point onwards. So this is what checkpointing does. Um, in AWS MSF, which is a managed service for Flink, it uses RocksDB to store the state and check state of the operators and checkpoint locations, checkpointing as well. So before we move forward, what is maintained inside a checkpoint? So this is something which is important to know. What is stored as part of the checkpoint? This is not the full list. This is a certain pointers only that okay, we should be looking at in this direction that what could have been stored. So for example, let's say if our Flink application is processing data from Kafka, so the Kafka offsets are persisted in checkpoint. If we are using Windows in our Flink application, for example, let's say a tumbling window or sliding windows, the checkpoint preserves the state of these windows. So this includes the elements that are part of the active window at the time of checkpointing. So that also gets persisted. If we are doing aggregations, let's say some count min max or any key-based stream operations that we are doing, so the intermediate result of these aggregations are stored in the checkpointing state. Timers and watermarks. So let's say if we are using watermark with the windows and we are leveraging event time processing, then the state of these timers, like the timer, like for example, if we have event time processing timer, then that will be also stored in the checkpoint. Custom state is also maintained in this checkpointing location because this if we have defined any state that needs to be persisted across failures, then that will go. If we have not defined any custom state, then it will not be there. But generally we define custom state as well if we have to process something which is complex in nature. At a high level, what happens is job submits their task to task managers, and task managers report back the response. But each task manager has its own local state, and during a checkpoint, all these state of the local tasks, all these local states in the task is written to a snapshot store, which is for the checkpoint location that we have, let's say a remote directory. There it's persisted. So in a nutshell, we can say that state in Apache Flink refers to the data stored by the operators while processing a stream, and these are often stored locally on the task managers. And checkpoints are the snapshot of the state of the entire Flink job at a particular point in time, and these are stored on the durable storage system. So there is a difference, like state is maintained at local at the task level. State is maintained in the local disk of the task instance, while the checkpoints are always in the remote directory. We can use any directory there where we want to persist, but generally it's good practice to use it on a remote location. Now different stages of checkpointing. So checkpointing, how it is done is there are three, I will say there are not three, there are five stages of checkpointing. So it starts with a waiting or start delay. So what it does, Flink will use a checkpoint barriers that gets inserted into the streams from time to time. So this what it does, it will the stage that is running, it will the operators for that will wait for the checkpoint barrier to reach it. So that's what the starting delay is, right? Then alignment happens. This is in what happens in all in a stage, all the subtask which has reached one barrier, but it's waiting for barriers from other input streams, so they will be aligned because so what is happening, let's say if you have a task, multiple tasks are running, so the first it will insert and start delay, then multiple subtasks will wait for the barrier alignment to happen. Once we have the alignment, the snapshots when it is being uh, means when the snapshot is being taken, it will block all the other activity of the task, and then it will take us means it will ensure that we are on sync. And then once the snapshot is taken, then there is an async duration. Majority of tasks at this upload the stage to the remote location. In this case is in S3, and the subtasks are no longer blocked and they can process. And once everyone has uploaded the uploaded the snapshot to the remote location, the acknowledgement happens that yes, the checkpoint has been taken successfully and snapshot is available. And this report is sent to the job manager to any do a commit. So this is how the checkpoint happens. Flow wise operator start states updates, change log, state backend. It has two different types. One is the DSTL where the state changes are maintained, and then we have the RocksDB implementation where we maintain the SSD files. So this is how the overall flow of a checkpoint uh, process in Flink. And why we so this is one common challenge that we see, that we will have large checkpoint, and if you have used Flink with AWS, you will always receive this error alert if you have defined in CloudWatch that your Flink application's state is growing or checkpoint size is growing. The reasons for checkpoint size growing is following, like it may be because of the state size. So let's say if our application is handling large amount of data, then numerous keys will be there and all those keys needs to be stored in the state. So hence the state size might increase. Then we might have a high event rate. So processing large number of events per second can also inflate the checkpoint sizes. We might have a large window sizes. For example, if we are using interval minus 1 day, so the whole 1 day's state will be maintained. So that is something can cause a larger checkpoint sizes. Retention history, that also is I mean, historical data. If you want to store, you have configured to store the historical data, that will also be stored in the checkpoint, and that increases the size of the checkpoint. Uh, uh, let's say if our application has any, if the application that we are doing has a key by operation and the keys are not distributed correctly, then certain state or certain checkpoints may be bigger, may cause a bigger checkpoint. Uh, the checkpoints may also be coming because if our let's say while taking a snapshot, if the GC has not happened, so all those objects will still uh, contribute towards a checkpoint state. And if the job uses key operator to partition incoming data and the key with the data has high cardinality, then checkpointing will slow down because will have to store the keys for many keys in different folders. So these are some challenges. These are some issues why the checkpoint size increases, and how do we monitor? So we have a Flink web interface which provides us this option of monitoring the checkpoint sizes. We have seen this in our last video of how to debug a Flink job using the dashboard. And if we are using MSK or some managed service, so they will have an alert definitely for showing what is the checkpoint size and if it is growing continuously or if it is going down and coming back up. So that kind of things we can take. There are two modes of exactly once or at least once checkpointing. Uh, the the difference is the way they follow the consistency versus the delivery guarantee part. And this simply says which one to be choose for which processes. For example, if we have chances of losing I mean, If we are tolerant to loss of records, then we can go with exactly once mode without replayable sources. But if we don't have that, let's say if we cannot lose any record, s- then we can't have a checkpointing mechanism which which we will have to have. And so at that time we will have to use at least once checkpointing mechanism. So yeah, that is some precisely can you can read it like the flow graph, which one exactly once, at least once, or no checkpointing at all. So that's so. But if you keep going down, it will increase the latency. So this is the checkpointing configurations that we can use. To optimize the checkpoint size, we can increase the parallelism of the processors. So it will process faster and hence it will have lesser state to persist. Uh, we can define TTL to make sure that the state is periodically cleaned. We can optimize the code to reduce the window size or the cardinality or number of keys which are present in a window that can be reduced. For example, if we use proc time, that proc time with retraction, that will help us in reducing the window size. There is other like for hop and tumble windows for deduplication. If we are doing, we can use proc time. Then we can also give hints like this, which says the TTL for this particular state is how long. Like we are processing our data from Kafka, and we are saying that here we have given a hint that the state should be only maintained for 1 minute. Uh, this is another option giving state ETL. So there are different ways in which we can do windowing. Uh, we can improve the windowing code to reduce the checkpoint or window size altogether. If you are in Flink observability, so there are two good projects out there in the market. One is Datorius or Datorios. This gives Flink observability, and there is another company called DriftDev. I have consulted them once or twice for their features when they were in early stages. So yeah, these two products are there, which allows us to do observability as a not as an afterthought, but as from the beginning itself. And it has they use certain jars which gets plugged into your Flink application, and then you get the best observability that you want for your system to be available. So this was it. If you like it, do share. Have a nice day.